In this video, we'll explore radiation and nuclear reactions. We'll start with talking about what radiation is, as well as what different types of radiation are. What are radioisotopes? How do we express nuclear reactions? And explore what is the band of stability and why it is relevant to radiation. Here are our relevant syllabus dot points. Before we talk about what the different types of radiation are, I think it's important to understand exactly what radiation is. Radiation itself is the emission of energy from a substance, and radioactive decay is the act of emitting radiation from an unstable isotope to try and make it stable. A stable isotope is one in which it is more resistant to chemical actions. Now, three types of radiation are alpha, beta, and gamma. The nuclear symbol for alpha is 42A. And if we check on the periodic table, we can see that the proton number of 2 corresponds with the proton number for helium. Beta has a -1 proton number, indicating that the charge of an electron, which is equal and opposite, but mostly massless for the most part, because if we remember, an electron is 1800 times lighter than a nucleon. And gamma radiation has no mass or charge because it is simply EMR. The charges given for alpha are +2, -1 for beta, and 0 for gamma. Poor penetration for alpha radiation being stopped by thin paper, medium penetration for beta, and high penetration for gamma. The ability for gamma radiation to be highly penetrative means that it's ideal for things like medical imaging or cancer treatment where it's able to go through flesh and bone. The velocity of alpha is going to be 0.05 times c, which is the speed of light. Velocity of beta is 0.99 c, so 0.99 times the speed of light. And gamma, because it is EMR, is just going to be the speed of light. A radioisotope is simply an isotope which is radioactive. Generally, we find radioisotopes to have an atomic number which is greater than 82, although 83 bismuth has the possibility of being non-radioactive. Radioisotopes are also rarely found in nature. Generally, radioisotopes are going to be found as artificial isotopes. Nuclear reactions are a type of reaction which we write to depict the radioactive decay of some isotope. We start off with a parent nucleus, which, unlike our typical chemical reaction, is the only reactant component. The radiation which decays is given on our product side, as well as the daughter nucleus. Now we can calculate the atomic symbol of the daughter nucleus by taking the mass number and the atomic number of the parent nucleus and subtracting the numbers by the radiation numbers. If we look at this example, we have radium-226, which has a mass number of 226 and a proton number of 88. It is undergoing alpha radioactive decay to release an alpha particle, also known as the helium nucleus. And we can calculate the daughter nucleus's atomic symbol by going 226 minus 4, that equals to 222, and 88 minus 2 equals to 86. The band of stability is a zone which demonstrates the nucleon ratio of protons to neutrons, which determine whether an isotope is stable or radioactive. And if we remember, it's stable if there is no radioactive decay. Neutrons stabilize the proton repulsion in the nucleus. So if there are too many protons, you can generally fix this issue by increasing the number of neutrons or decreasing the number of protons in an isotope. If we look at the band, we notice that there are no isotopes which exist beyond a proton number of 83. This means that all isotopes with a proton number greater than 83 are going to be radioactive. And the reason for this is because at that point, the strong nuclear forces which hold together the nucleus can no longer overcome the repulsive forces between the positive charges of the protons inside of the nucleus. We can use this band of stability to help us predict which mode of radioactive decay an isotope will likely to go through. If an isotope is neutron-rich, then is likely to undergo beta decay, whereby a neutron will decay into a proton and an electron. The ejecting of the electron will then increase the proton count by 1, while decreasing the neutron count by 1. Now, if it is neutron deficient, then it will undergo alpha decay, where it can move diagonally down the band. This is effective because the necessary neutron to proton ratio for stability decreases as we go down the zone.